So if you just go to Google and you type in mini REFPROP as a search, you'll come up with this reference site right here. Now this is NIST, it's the National Institute of Standards and Technology. It's federally funded, and you can click on that and get a mini version of REFPROP, which is a sample version of the full REFPROP program, but it's limited in the number of properties. So it has a number of properties: water, CO2, R134A, nitrogen, methane, propane, hydrogen, and dodecane. And you can, as a student, you can get this limited, it's a full version with a limited number of properties or fluids. And they're not going to support it, so you can't call them for any help, but you can download it and install it and use it. So what you would do is you'd run that program, and you would want to create in the C drive, I believe, somewhere in the program files folder, a mini REFPROP folder. And inside that folder, you would have fluids, mixtures, and this. True? And then last time, did I fire this up for you and demonstrate it? Okay, so what we can do is we can fire up this REFPROP. You could put it like under here, right? Where do I have it? Right here. And it's just a software program. So what we see is we have a file, edit, options. Let's go under options, and you can play with whatever units you want to work with. You want to work in Kelvin, degrees C, Fahrenheit. You can mix them all up. But typically you stay with like SI with degrees C, maybe molar SI. So these are, you can click these preset buttons, or even English. So degrees F, PSI A, BTUs, pound mass, pound mole right there. So let's leave it in degrees F, the PSI A. We'll click OK. It's on a mass basis or primarily a molar basis. There's a lot of options in here. Let's take a look at different substances. So you can have the substances that they give you are carbon dioxide, and here's that list: dodecane, hydrogen, methane, different substances like that. And you click OK. And then you can say, what do I want to do with this substance? Let's calculate at specified state points. So let's say I want to know for methane, the entropy and enthalpy and density as a function of temperature and pressure. Let's put in 70 degrees F and, I don't know, 1500 PSI. And there are the values. So you can evaluate properties. If you want more properties, go back to the options, look at properties, and say I want specific volume, internal energy, specific heat, speed of sound, Joule-Thomson coefficient. There's a lot of properties, aren't there? And then these are just the thermodynamic properties. Transport, they have thermal conductivity, viscosity, kinematic viscosity, thermal diffusivity, Prandtl number, surface tension, dielectric constant. Oh, you want derivatives like we've just covered in this chapter? So you have all of these derivatives. Here's your isothermal compressibility, volumetric expansivity. That's that beta. True? Okay. And then special, hey, do you want the flow exergy? We studied that already this semester, flow exergy. That's where you would find it under a special property. And then if there's mixtures, then you have different things that apply there. But let's go back and unclick some of these because I don't want such a long list, but that should be enough. So we'll cancel here, say let's go ahead and calculate at specified points, and now we see Joule-Thomson is over here, isn't it? And so let's go ahead and calculate, 75 degrees, what did I say, 1500 PSI, and so you can see the specific heat and then the Joule-Thomson effect. What does this Joule-Thomson coefficient, can you read it? It's 0.040. It says that if I'm going to have an isenthalpic expansion at that point with methane, starting at this point, it'll be 0.04 degrees per PSI drop, pressure drop, or put it in the 100 PSI pressure drop. It would be about 4 degrees F decrease in temperature for every 100 PSI drop across a valve. Also, you can plot, and there's a lot here. Let's take a look at a temperature entropy diagram. And you can plot, just if I don't click anything, and I'll just click OK, there's a plot. All right? And you see that they have the 100 psi. I've pre-worked this, and so it has some stuff set in it already. This wouldn't be your natural first plot that you would get. Let me see if I could go back and unset some things. But let's put on lines of constant enthalpy into the two-phase region, and there you go. This is lines of constant enthalpy going into the two-phase region. All right. You want to change the temperature scale, you can do that. You would think that that would work. So the x-axis, the y-axis, maybe you want to go up to, I don't know, 100 degrees F. So there you go. You're up to 100 degrees F all the way down to negative something. This is the dome. These are lines of constant pressure. So you can continue to update the plot. The pressure, it's from, let's do this, from 100 psi to 2000 psi in 100 psi increments, which will be too many lines. That's a lot of lines, true? But what you can do is go under plot, and you can modify the plot. And one of the great things is you can delete this one at 1800, 1700, 1600. So maybe you just go, once you're above 1000, you just go in increments of 500. So I'm going to have a line that is maybe, let's see what else I'm going to do. I'm getting rid of those isobars. There's a lot of isobars here. Let's get rid of this one. I don't know why there's so many of them. Let's go ahead and plot that. So you can see I've gotten rid of some of these isobars. And it's still clustered, so I would get rid of more and make it pretty. Okay. These pressure lines don't extend into the two-phase region, do they? We could probably modify that plot. Connect saturation states. Okay, you sound like you've already used this. Excellent. So there you go, it did it. Thank you. So you can do a lot with this software, and it is available to you. If you want to pay for the full version, it costs maybe $500.